Good morning, everyone. Good evening. Welcome to another episode of xahlee Talk Show. We are going to code Wolfram language today, pure Wolfram language. If you are watching this offline, play at 1.5 speed or faster. If you are watching this live, say hi. Okay, so we're going to code Wolfram language today, pure Wolfram language. I'm going to demo xahlee Wolfram mod, and I'm going to demo Wolfram language, okay, and demo xahlee Wolfram mod. You can download for free. I'm going to show that. Then I'm going to demo xahlee Wolfram mod, and I'm going to show a problem which I'm going to code. So, for example, let's go to xahlee Wolfram mod. So this is a package for Emacs users, for you to code Wolfram language in Emacs. I'm going to show you a problem I need to do that involves the symbol concept. The symbol concept in Wolfram language is like function names and variable names. In other programming languages, you call them identifiers, such as C, Java, JavaScript, C++, Rust, Golang, identifiers. So I have a completion feature, but I need to determine what type of the name is in order to do the completion properly. So if it's a function, you want to add, the brackets. If it's not a function, usually an option in Wolfram language, you want to add an arrow sign. But it's kind of difficult to determine that, okay? So let me go over that. So basically, that is we're going to explore. Then we're going to talk about the Wolfram language symbol, which is very advanced topic, and this is not a practical topic. So if you're gonna learn Wolfram programming language or Mathematica for doing engineering, mathematics, or programming, or artificial intelligence, or cryptocurrency, or cryptographics, you wouldn't need to know what we are doing today. So this is kind of for myself, and this is for those interested in programming languages, and especially like Lisp family where you have symbols. Okay, so let's begin. Let's go from the beginning. Okay, so from the beginning, today's talk show. Let me check one more time. So we got 3 people watching. Say hi. So we gonna is my video good? Let's check video, check audio, check. Okay, so let's begin coding. Okay, so let me begin from the beginning. Of course, play at 1.5 speed if you are watching offline. Okay, so first of all, let's demo the Wolfram script. Okay, Wolfram script. Let's magnify. Control. Let's magnify. Okay. So Wolfram script, you can download for free. So you begin. So okay, so let's say expand bracket. Then let's say x squared minus y third power times square root of x, let's say square root of y. Okay, let's make it kind of fancy. Let's see what happens. Now let's see, where's the close key? Okay, so what? Close paren, close, and we need to make it third power. Okay, let's see. Let's do that. Oh, that's simple. So anyway, so this is demonstration of Wolfram script. Okay, and so you search for xahlee Wolfram, xahlee.info, xahlee Wolfram language tutorial. You can find here's my download. Here's Wolfram language for programmers, entire tutorial for those of you programmers. This does not teach you how to solve equations or do calculus. There are plenty materials out there. But this is for programmers. If you know JavaScript, Python, Java, C, if you want to learn this kind of artificial intelligence language, far more advanced, then this tutorial is for you. And over there, you can go download. So go to this website. exactly this website. Okay, don't be fooled by other website. This will take you to the Wolfram research page. Turn on JavaScript, and you can download it. Okay, it's something like 4 or 5 gigabytes. So this is a huge language. You got 7,000 functions built in. Very different from all languages, or from Lisp, from Common Lisp, from JavaScript, from Python, from Haskell, from Rust, from OCaml. Very different from them. A magnitude higher level. Okay, so you download it, then you got this Wolfram script. Okay, so that's Wolfram script. Now let's shrink it. Let me do a screenshot so that we already did that. Okay. So anyway, so that's where to download for free, or you can pay and buy it. Okay, this download is for personal use. Check their license agreement and so on. So let's go back to today's talk show. So demo Wolfram script we did. Okay, then we download Wolfram engine. That's where you download. And if you want to have graphical user interface, so here's Wolfram language I already opened. You can have a graphical, let's say plot. Let's say parametric plot. Parametric plot 3D. Okay, let's do a fancy one. 3D. Now, it's kind of tedious to type in the Wolfram language, so I usually do in here in Emacs. So let's go. We need to go faster because I need to cover lots of other things. So start the Wolfram language, pop it out. So Wolfram parametric plot 3D. So you want to plot. The first one argument is the expression. The second argument is the parameters. So x and y parametric plot 3D. So let's just say, so parametric plot is a function of two variables. That's the input. Then the output is a vector of 3 numbers. Okay, so let's say cosine. Okay, cosine x, sine x. Then let's just say t. Okay, so x from 0 to 2 pi, let's say times 2. So that's basically 0 to 4 pi. Okay, let's give it another parameter. This one is t. T goes from 0 to, let's say, 5. Okay, that is the syntax. Wait. Copy it. Let's magnify again. Now let's go here, paste it, plot. Oh, so you got this cylinder. Wait, I just wanted to be a helix. So what you need to do is, so sine xy, so you need to type. I'm not sure I know this is correct, but let's just experiment. Oh, you got a cone. Okay, so what I'm saying is that if you want this graphical user interface, then you also need to download, you download the Wolfram engine, which includes the Wolfram script, but this is, but this is only for, text interface. So let's do, where's the key? Okay, so let's say pi to 100 digits. Okay, enter. There you have it, pi to 100 digits. So, but this is textual interface. If you want a graphical interface, you need to also to download. So just read my page. Okay, my page explains everything. You download the Jupyter notebook extension there by Wolfram Research. Okay, so that's official. But there's also another one. So if you go to Jupyter notebook, Wolfram language for Jupyter from Wolfram Research, the official one. So turn on JavaScript. Okay, my alarm clock. my alarm clock tell me to get up every hour and walk. Otherwise, to prevent ass rot from sitting too long. So you get the Wolfram Jupyter notebook, so you can have this graphical interface. Okay, and then you also and there's another one. There's another like competing one similar. But anyway, so you look, if you are interested, read my documentation. So I have lots of details. Okay, so that's parametric plot. We want to get a helix, but that's not helix. So this is about mathematics. So what is the? You need to get it right. I forgot exactly. So I know. Okay, so you in that case you just but we are wasting time. Okay, so but anyway, so sine cosine so it's all x, so the input is just one variable. Okay, so sine or cosine, so I think that. Okay, so paste it there. Oh, extra comma, delete it. There it is. That was what I was planning to do. Helix. Okay, fantastic. Okay, so that's demo of the graphics. So you need a notebook for that. Now put it back. Syntax correct. Showing browser. Today's talk show page. We demonstrated that. Okay, so now let's demo Wolfram mod. In fact, you have seen this is Wolfram mod. You can see Wolfram at the bottom. So this is this is coding Wolfram language in Emacs. So I can type para, tap enter to do completion. So I can type parametric, so there's parametric plot 3D. I can do completion. There it is. Press enter again. Okay, there's no completion for that one. But anyway, completion and and all kind of features. So press tab, then H, that shows all the commands you get. So you can complete symbol, eval buffer, format, compact format, doc lookup, eval current line, eval region. Let me show you some of them. So this is Wolfram mod. Okay, so you go here. It's free, thanks to Wolfram Research. So on this page, you go to download, which is GitHub. Then you can get it. Okay. Now here are the commands. Let me show you a few. So let's demo a table feature, which is most powerful. So let's say a list from x and x squared, okay, and x from 1 to 5. So press your Wolfram product is not activated. You get this error when you run too many instances. So let me exit this one. Exit. Okay, so exit, then copy it. Okay, great. Make a screenshot. Okay, so now exit that, then okay, and then delete that. Now press. You see, here is the output. Now you can see the command calls on the pink window. Wolfram eval region. Tab R, that's a key. I'm using a Aurora keyboard, by the way. I'm also using xahlee keys. Xahlee keys, that's another package. If you watch my videos, you search for it, you'll see it. Let's go to it. Let's go to the top. It's on this home page. Showing browser. It's a key binding system for Emacs. I have tons of videos about that. Okay, so anyway, let's go back to Wolfram mod. Okay, so again, remove that. So you can do completion, you can do evaluate. Okay, so let's go to look at the source code. So what we want to do? Look at the source code. Okay, so describe key, press. Okay, there it is. Wolfram mod. Okay, so now jump to the source code, open it. Here's the source code, about 3,000 lines, but most of it is function names because the Wolfram language has 7,000 symbols built in. Like out of the box, there are 7,000. In Python, when you want to do regular expression, you need to load regular expression library. When you need to go through a directory, you need to load system library or file util library. If you want to do, networking, you need to load networking library. In Wolfram language, it's different. Everything is just a function call. You don't have to load whatever. So by default, there are 7,000 function names built in. So this will show them all, including there are about 100 or 200 special characters. So these are all the function names, about 7,000 of them. Okay, so you can see we can, then you can also, so then let's copy from the last input // that's a postfix notation. Then you want to say length, so that will tell you how many there are. Shift enter, 7,500 functions built in out of the box, from artificial intelligence, from cryptographics, from mathematics, number theory, differential equations, calculus, differential geometry, graphics programming. Okay, so this is so huge. Let's delete the output. Graphics programming and all sort of things. You can build, you can also interact with C or Python, or you can also, for those of you new generation, you do makers, like you create, you buy the Raspberry Pi. By the way, Wolfram language came with it. If you buy the Raspberry Pi, you can see I talked about here. So download Wolfram engine, go to that page. You can see if you buy Raspberry Pi, it bundles with Wolfram language for computing when you are on the Raspberry Pi, but you cannot install on your PC or whatever. It's just for the Raspberry Pi. So a lot of younger people today, they are not, exactly programmers in a traditional sense, but they do, they build boats, drones, whatever, all kind of devices, but you also need to program. So you can use Wolfram language, you interact with that. So AI, lots of things. Okay, so another feature in Wolfram mod is, for example, if I want to know the documentation for this function, I just press a key. It goes to the official documentation. Okay, so this is parametric plot. Let's magnify. Okay, so now you can see the full details about this tremendous functionalities in this parametric plot. Like to write this function, the full capability to write this function in Python, it'll take you 100,000 lines. Okay, minimum 100,000 lines, because it can not just do or two-dimensional or one-dimensional parametric plot, but it also can plot part of the region. So there's a lot, like to just study this function takes several days just to know all its capabilities. This is just one of them. Okay, one of the plotting functions. Now this thing you are seeing, it's a famous curve in differential geometry. It's a model of hyperbolic geometry, model of a two-dimensional hyperbolic geometry. This is called what's the name? I forgot the name. I have it on my website. But anyway, so what I want to show you, so we demonstrated many of the features of the Wolfram mod Wolfram mode for Emacs. It allows you to code Wolfram language in Emacs. So I was talking about but what does Wolfram language do? So you go to their documentation, so you just go to built-in symbols. So where do we go? By the way, they just had a new design of their website. So this is their new design. I recognize many of these images. For example, on left-hand side, most of these, all of them are from 1990s when I began to use Wolfram language. The one on the left, and then I think they are chronological. All these are like history of Wolfram language. So I recognize most of it on the left. So anyway, it's tremendous things you can do. Artificial. So they actually talk about it: economics, data science. What is this? FinTech. I don't even know what is FinTech. Software engineering, statistics, computer engineering, game tech. Like game programming, cryptography, system analysis, computer science, computer science. That's a part I know well. Electrical engineering. So they are showing this is inversion. Actually, this is a plot of complex numbers inversion. We talked about it, last week also, many times before too. Planetary science, you can plot that. Can we show it? Yeah, I can. Like all of the management science, mining, automotive engineering, utilities, transportation, energy. Wow, that's getting fancy. These like the life sciences and chemistry. But the main thing is like all this. But it's a programming language. So it does all mathematics known to humanity. Any algorithm that is known, any algorithm in computer science, including cryptographics, including number theory, including computational geometry, including, of course, analysis and algebra, including, basically everything, including artificial intelligence, machine learning. So anyway, so that's kind of that, the scope of Wolfram language. That's why I say it's like a magnitude different from all the industrial programming language. So here is machine learning. You can also do video and image editing, programmatically. And machine learning, you can also, just have it predict what kind of category, categorization, kind of different things in machine learning. Okay, so that computational journalism. Anyway, that's a new new website design from Wolfram. This just came out like 2 days ago. Okay, so let's get back to what we were doing. So that's, all the before is like introduction. Okay, so let's put this back. Syntax correct, showing browser. So we covered demo of Wolfram script, download Wolfram engine, demo of Wolfram mode, yes, and show problem of completion. Okay, so let me show you what is a problem. That is a problem I need to do. Okay, so let's do this again. So for example, if you have a table, what is this table, what it does is like it's analogous to Python programming languages list comprehension. Okay, so it's called list comprehension. So if you don't know, list comprehension. So why list comprehension is bad? That's about programming language design. Okay, I have an article on that. And here is, list comprehension, Python semantics and syntax and the hacker idiocies. That's another one of my rant. There it is, a tutorial of what is list comprehension in the Python programming language. Basically, it's a special expression, special syntax to allow you to generate any kind of nested array. Okay, that is what it is. List comprehension is a special syntax within a language that what does it do? It allows you to generate nested array. Okay, so if you don't have this feature in your language, you can do the same by nested loop. Of course, it's more cumbersome, for I, I equals to something, I less than something. Then for j, you do 2 loops or 3 loops if you want 3-dimensional array. But list comprehension make it easier. Okay, it generates nested array. Now in Wolfram language, you don't have this so-called list comprehension because it's kind of idiotic, in my opinion. But you got this function table. What does it do? It does exactly what this list comprehension do. It's for generating nested array. Okay, so for example, this is flat array. We are explaining. So let's say just x from 1 to 5. Press. There is a result, flat. This is also flat. What if you want to do 2-dimensional array, nested array? So you can say f something, x, y. So x from 1 to, let's say 2, then y from 1 to 3. Okay, and what you want is a fxy. Okay, so now you run this. Fantastic, you get that. Okay, let's kind of can we clean it up? Well, let's make it formatted. So one of the thing I don't have in xahlee Wolfram mod is that I don't have the ability to format the code. So I need to code that. That's one of my to-do. So anyway, this thing generates this output. Okay, so that's a 2-dimensional. So you can run exactly the same thing in the Wolfram notebook. It'll be prettier. And you can say slash is a postfix notation. You can say tree form. Then it shows you as a tree. So this is this demonstrate the power of Wolfram language. You don't usually see this in other languages. They don't do things like that. So that's that. So what I'm trying to say here is that this table is a function. Okay, it's a function. Now but some other symbols are not functions. So let me show you. Okay, so what is this parametric plot? Okay, so this is a curve. So let me show you. So if you do this parametric plot, obviously that's a helix. Okay, now I don't want this to be that long, so let's reduce it. Okay, so that's a bit shorter. So suppose I wanted to show us tube. Now is there an option to, right now it shows us a line, but usually in some situations you want it to be a tube, so it's prettier. So I don't know how to do that. I don't remember. There's 100 options. So let's look. Okay, so let's say for example, I want the background black. So there's an option. So let's say back, BACK ground. There it is. Background light blue. Okay, there's automatic completion. So shift enter. There you have it. Okay, so you got this. Now, okay, now I get it. So you see, when it's not tube, it's hard to see. Sometimes you see the flip of it, so it's became weird. So anyway, my point here is that this background is not a function. It's a symbol, but it's an option. So when you have a function, typically it's followed by the square brackets for the arguments. But when you have an option, it typically is followed by a right arrow. Okay, so in my Wolfram mod, I want to be able to say, for example, I type background, BACK completion, there it is, background. Okay, I want to then it automatically type a red arrow like that. So I can say red. Completion, red. There's a red color, So, but if this thing is a function, it automatically add a bracket like that. Okay, so that's what I want. In order to do that in my package, I need to know, which of these name is this an option or is it a function? That is like what I'm trying to do. Okay, but now we can go back to the question of how do you make this a tube. So you can view the documentation inside. So, okay, that's a surface, but okay, I don't know. But what you can do is you can, let me show you how. So we are digressing, but this is an interesting question. You call options, that's a function. So press, it should automatically add the brackets. Then you give it that, then you evaluate it. So there you go. So these are all the options that is available for the parametric plot 3D. So now it's one line. Let's make it multiple lines. Okay, so let's let's do it again. Okay, now it's okay, now it's not too good. Anyway, so that now it's one option per line. So is there some, so now let's search for tube. No, you don't see. Okay, so you don't see tube. Let's search for style, plot style. Okay, anyway, I was trying to make this line to be a tube, but I don't know how to do that offhand. I'm sure I can find out in 10 minutes, but it takes time. So let me just try something. Then if it doesn't work, we'll forget it. Okay. Plot style, let's add a I don't think it work. Okay, no, that's not how you do it. Anyway, so let's forget about that. Okay, so let's get back to our main thing. Our main thing is the question about, okay, hold on a second. So what we're gonna do, let's put this thing back in here. Okay, so now put it back. Wait, pop it out. Let's separate, put it back, syntax correct, show in browser. So we talked about all these things, and here's our sample code. So now the question is, here's a question. I asked AI about it. So Grok AI, so let's see, where can I find, let's not go over there. So I asked Grok about this question. In Wolfram language, how do you determine if a symbol is a function or a option name? Here's a question. And here is Grok's answer. So let's go there to see the Grok's answer, okay? Magnify. So it says, in Wolfram language, there is no single built-in predicate like the hypothetical function Q or option Q to definitively classify a symbol as a function or option name. So it's saying there's no built-in function to do that. But however, it's suggesting that you can do it by checking this or checking that. So this is a probabilistic approach. You might call it probabilistic algorithm, meaning that it returns an answer with a probability of correctness. Okay, so in other words, it's heuristic. So let's look at how it does. So let's try. Maybe we can. Maybe it'll work. Because what I need to do is I need to apply this function to the entire 7,000 built-in symbols. Okay, paste it. Let's pop it out. Okay, so the AI chatbot is suggesting this. By the way, I already know this. I want to know if there's a single built-in function. It says no. So let's explore, what it does. Let's explore what are the ways in order to determine if a symbol is a function name or is it just an option name. Bill Hernawang, Financial Technology. Good morning. Okay, so here what Guok is doing is writing a function. So you can see it defines this classified symbol, and here is the pattern for the argument symbol. Then it's a module. This is a local variable block like Lisp's let. Okay, and here it defines two local variables, usage and name. So the usage is basically that. The value of usage is that, and what that means, it returns the inline documentation for the symbol. Okay, let me show you. Okay, so remember previously we were talking about the table function, which is lets you generate nested arrays, right? So here's an official documentation, nested arrays, and you can see examples. Okay, but we think that you don't have to go to the website. You can look up the inline documentation. How you do that? You do that by just not that. So you need colon usage. Okay, so you just evaluate this. Okay, let's try. There it is. So it's kind of verbose. There's a lot. So it's it says that okay, this is not good. This this is unreadable. But what actually it is, it's a formatted. It's using Wolfram language to produce a formatted output. So this display form, raw box, something, that's just like markup, like the markdown, language or HTML. So but this is a Wolfram syntax to format the display. But if you run this in Notebook, let's go to the Notebook. So if you run this, this in Notebook, you see now it's beautiful. It shows the inline documentation for the table function. Okay, so that's what this let's highlight it. Okay, usage and name. It assigns the inline documentation, which is a string. Oh, actually, here it's not a string, but actually it's not a string. Oh God! So that means you need to parse this. That's not trivial. I thought this is string, but you can turn this into a string. Okay, so let's. Anyway, so this is what this syntax means. Okay, it's just the inline documentation, but it's not a string. How can we turn it into a string? I think, for example, let's see, what is this? Can we? Okay, so this is actually one giant expression here. Oh wait, this is a string. This whole thing is a string, but I think you see. So you see this. Let's see. Yeah, this whole thing now, but well, here's how we can test if it's a string or not. So what we call string q, that will return true if this is a string. Okay, so cut that. Let's go down. Put that there. Run it. True. So it actually returns a string. So that is interesting. So this thing is a string, but you see, normally Wolfram language doesn't print the quote, so that's why you don't see. Let's see. Can you search for the quote? No, it doesn't. It's not there. So, but let's put them into a quote. Okay, so let's put them into a quote. There. Okay, and now if we cut this and paste this here, will it format? I don't think so. No, it doesn't format. So Wolfram language in Notebook, it has special, it's doing special magic. Anyway, so what is that? By the way, you can get the stream form. Actually, you can, so. Okay, so you understand what this is. Okay, it returns a string of the. It returns a string of the inline documentation. Okay, but to actually make it a string format, you need to use a full syntax for that. Okay, I have. So let me check my Wolfram language tutorial. So here you go to print version, building help. That's what you want. Okay, so that is what you want. So you want to just say information table. Okay, cut that. Let's go down here. Paste that. Put this into a comment. Run this and paste output. Okay, it still doesn't. It returns this thing, information box. But I'm sure text form. You need to get it. Okay, so let's try this again. Text form. Run it. Okay, now it's text form, but it's ugly. Table n generates a list of copies of n, and then table that generates a list of value of that from 1 to I. Then that it's ugly. So anyway, these are the flaws of using Wolfram script in a text interface. So this is when you actually want the notebook interface, because the notebook interface will just return this, with sometimes with math typesetting, like a fraction or radicals. Okay, so anyway, so let's go back to the problem we have. So we a very technical issue. Are you guys doing good? And am I doing good? Shall I continue? Is this interesting? I don't think it's interesting to a lot of people because it's very kind of technical and boring. But okay, let me just do it for myself. Let me, talk for another 10 minutes or so. So basically, you get the symbols documentation, then you check. So obviously, this function generated by AI is not gonna work. Yeah, I don't think so. But what it's trying to do is it gets the get the inline documentation of the symbol, then check if it's a string. If it's not, then undefined. Okay, that does not always work because I just kind of know from experience, 30 years. Then if string start with Q, usage name is an option. So it basically it looks at the documentation. If the documentation begin with some function name and bracket something something, then it's highly likely this thing is a function. However, if the documentation says, for example, let's say we just tried the background before, so shift enter. If the document says something something is an option something, then it's highly likely that this background symbol is a option. So by the way, this question mark table. The question mark is kind of a convenient syntax for this usage. Okay, so but you can kind of see this table something something usage, it returns exactly the same as this, but the question mark make it formatted. And then you can click on here to go to the actual documentation, with examples and scope and generalization and extensions and applications and properties and relations and possible issues and other C also kind of related functions. So anyway, so this approach, you try to get the inline documentation and check if the string begin with a something symbol name and bracket, then it's a function. If it begin with something is an option, then it's an option. That's how it does it. Okay, so I need to run this over the 7,000 symbols built in. Okay. So I need to do this for the over 7,000 symbols built in, and preferably I want it to be able to run this in a text terminal in Wolfram script, not via the Wolfram kernel, the notebook. So I need to get this part fixed. I need to be able to return a plain string of this part, not wrapped by the display form, the row box, style box. That's what makes this format. You can see there's a subscript, there is italics. You see, that's what this style box and box, that's what those are for. But I just wanted a text format. But oh yeah, we did this here. Oh yeah, actually, yeah, so this will work. Okay, so we need to, so let's remove that. Okay, so actually, this box. So let's try it again. Text form. Okay, it actually kind of works. Now let's call postfix notation / string. String Q, is it a string? Is a return value a string? Oh, it's not a string. Shit. Oh wait. What? Text form is not what you want. You want to convert it to string. So how do you there's no text form. What? That's an interesting kind of bug, because text form should be a valid function. What? Let's run this in notebook. Okay. Run it. So it's not a string. Shift enter, run it. So it does return text form. And now let's look at the documentation. Search result. So actually there is no. So the search form function is actually not documented. That is what's happening. The search, that's interesting, you might consider this a bug. The text form function is actually not documented, which is very rare, okay. There's a few, but so among the 7,000 functions, it is very rare, let's say one in 1,000, that it is not documented. So, but it suggests string form. Okay, I think that's what we want. Where did I find the text form? Or did I just cook it up? I found it somewhere. But anyway, I think what we should use is string form. Okay, so let's do it again. String form, that's the one we want. Run it. As your force. So text string, so wait, so how do you convert to string? So now let me just look. Okay, so let me look, built-in help. Let's go to string section, open a new window, new tab. String, here is everything you need to know about string. Then regular expression, string expression, string template. You want to convert an expression to string. Okay, so string functions. Okay, so convert string there. Okay, to string, that's right. Well, that's, I'm not sure that is right. So, okay, so let's try to string completion. Run it. True. Now let's see what it actually returns. Okay, so remove the postfix of string q. By the way, q means question. Okay, you see that q? Any function name, if it ends in q, that means the function returns true or false, always, either true or false. Q stands for function. In other functional programming languages, such as Lisp, Scheme, or some others, they call it predicate. Okay, so usually they end in P. For example, in Scheme and Ruby, any function that returns true or false, the name ends in a question mark. Okay, but Wolfram ends in Q because question mark is not allowed character. Okay, so let's see what this returns. Okay, run it. Okay, so now this actually returns a string. Okay, so you see, so this is a string. So I can call the function. So table is one of the 7,000 functions. So do a map on each one of these symbols. And it returns a string. And check if the string begin with something of the form something bracket. Then we know this is a function, this table. If doesn't, okay, so actually this is doable. I can do this. Okay, so shall we do it? Yeah, we can. Okay, so we can actually start to modify this, whatever this AI suggested solution. We can start to write it. let me try this quickly, okay? Let me just try this quickly. Then we shut down, okay? Let me see. Let's see if I can. So here is an example. So I don't want a module, okay? Block is a local dynamic scope, okay? Then okay, so this part is a symbol. I want to rename sim by sim by xsim, make them unique, okay? Wow. Okay, not okay. Anyway, so this, so cut that. This you don't want, you cannot use this, okay? Paste that there, okay? So you get, so usage is a string, copy, replace doc string, okay? Rename it doc string, okay? Then this name is a symbol's name, that's a string, okay? So let's rename it xname, okay? Do it, okay? Then next, if string q, if not string q, doc string, okay, otherwise if string start q, doc string name, so this means string join, okay? That, that this is a syntax, shortcut syntax for string join. So it just join the symbol's name with something option, okay? Actually this works, so let's just run it, okay? If string contains something, if string start is an option, then it's an option, otherwise, so this is a if statement. If that, then so if not docstring that, then another if statement, okay? Then if string start with something is an option, then output option, then another if string contains something left bracket, then its function, otherwise other, okay? Let's just run it. So that, then let's call it on table, okay? Table is actually a function, so okay, let's run this. Let's see what we get. Function, fantastic. So all we have to do is just change this one line from the AI suggestion, okay? So let's try again. Now let's try background, that's an option, okay? Let's run it. Function option, fantastic. So it actually worked. Okay, I think that's it for today. So actually worked, fantastic. Bye guys, hope you guys like it. Okay, so now let's put this back, syntax correct, show in browser. So that's we successfully, kind of successful. The next thing to do is to try to run this function on the 7000 actually we can try that. You know, the 7,000 built-in functions. Let's try that. Let's just see what we get. But okay, so but let me prettify this a little bit. WOOL Wolfram code, and let's pop this out. Let's go to the bottom. Let's cut that. Okay, put it back, and let's put the new code here, syntax collect, and show in browser. Okay, so here's our code. Paste it, classify symbol. Okay, so let me do something else to it. Okay, clear. Let me just we add a clear so that every time we rerun it, we reduce problems, because sometimes previous definitions screw things up. So this clear is just clear the value just to be convenient. So we clear it, and also we don't want this part. We just want this part. Okay, and then we need to get all the functions. So that would be names, that then a bracket. I mean then we say that. So that returns all functions. Okay, so which is a list. Okay, so we can kind of run it. It returns the 7,000 functions. Okay. Okay, then what you do? Then you want to map. Okay, so let's delete it. Okay, delete. Then you map classify our function to this list. Okay, that's what. Okay, copy that. Let's just run it here, paste it. Okay, and that not so large, 150. Okay, so now we run it. Shift Control D to separate them. Shift Enter to evaluate that. Now Shift Enter. Okay, some of them doesn't return show more. Show more. Okay, so for a lot of them, you see these are built-in variables. So when they so when the value is a built-in variable, you don't want to deal with it. You want to ignore it. And when the value is a named character, you also want to ignore it. Okay, so let's say show more. Show more. Where is the true false thing? Show more, 7,000. Okay, you want to show all. Let's say show all. Okay, so for actually they don't return. You see? For example, let's run that. None of these return true or false. What's going on? Let's go down. Let's go down. Let's go down. Yeah, none of these return true or false. So what is going on? Oh, because they are not symbols, they are strings. So then you need to, so you need to turn the string to symbol. Okay, so instead of that, you write a function. Okay, then classify, and you want to turn a string to symbol. So that is that. Okay, x. Okay, function x classify symbol and turn the string to x to symbol. Okay, so copy that. In fact, let's shorten it. Let's say all names starting with T, so we don't have to deal with 7,000 symbols. Let's just test it. Oh, there's only what? Other. Why is just, oh, not T must be capital. Okay, capital T, because all built-in symbols start with capital letters. Okay, now it's running. It takes some time. Wait, it looks like I saw the result briefly. Okay, I think that's it for today. Okay, now we got set error, set accuracy, requested accuracy, which GIS travel dump kilometer greater than 1 something is not a real number. Okay, so it's running into issues. It's not as simple as that. Anyway, oh, here's a result. Okay, so actually most of it works. It tells you, so we need to modify our code so it returns not just what type it is, but also the name of the symbol. Like, so we know which one is which. But from here you can see it actually works. Some of them are functions, some of them are option, some of them doesn't return a result because the input is not a symbol, it's an expression. So that means we also need to fix our input, which is this name thing, so it only includes symbols. Can we actually do that? Yeah, we can. We can do that. So some of them are a date. You can see it pops up a date, today's date. Yeah, and some of them are, what is this, gray level 00 transparency. So that is black and transparent. That's what that represents. Okay, but mostly it works. So with a little bit more fix, then we have it. We'll have a function that can classify of the 7,000 built-in symbols, whether they are a function or an option of Wolfram language. Okay, that's it for today. Thank you guys for watching. Bye. Bye. You are late. If you watch it from the beginning, you'll understand what I'm doing.